All right, I'm just finishing up the alternate interior angles theorem because I didn't write angle 4 is congruent to angle 5. And you'll notice that they're alternate interior because they're on the insides of S and P, and they're on opposite sides of the transversal T. Okay. All right, so just like last time, I'm going to erase the alternate interior angles theorem, write the other theorem, and then do the next work with the next theorem. All right, so the alternate exterior angle theorem said that if two parallel lines are crossed by a transversal, then alternate exterior angles are congruent. So we're going to do our statement again. Since line S is parallel to line P, we've got the beginning of this alternate exterior angle theorem. We can say that alternate exterior angles are congruent. So angle 2 is congruent to angle 7 because they're on opposite sides of T on the outside of S and P. And also angle 1 is congruent to angle 8. Okay. So again, notice I'm just using the same angles from that original drawing. I notice that 2, 7, 1, and 8 are on the outsides of S and P, and they are on opposite sides of the transversal T. Okay. Take a minute, pause the video, make sure that you get this definition written down, and then we're going to go on to consecutive interior angles theorem. All right, consecutive interior angles theorem, says that if two parallel lines are crossed by a transversal, then the consecutive interior angles are supplementary. Now this one's different, and it's different because they're on the same side of the transversal. And since we know opposite sides are congruent, we know that the same side has to have a different sort of relationship. So if I'm making this statement, I know that since line S is parallel to line P, I know that angle 6 plus angle 4 equal 180 degrees because that's the definition of supplementary. They sum to 180 degrees. And these are consecutive interior because they're on the same side of the transversal T inside lines S and P. Okay. On a similar note, I can say angle 3 plus angle 5 equals 180. Okay. All right, so that is all 4 of the theorems that we're going to talk about today. And it's basically just saying that if you've got parallel lines, then guess what? You have angle relationships so that you can find missing angles. So I'm going to start a new page, and on the new page, we're going to do some example problems, okay? So make sure that you pause this, you get that written down, and then we're going to do some example problems. All right, so I've drawn my 2 parallel lines crossed by a transversal. I'm going to label them. This will be line S and P and line T again. So I know that line S is parallel to line P, and that's because it's marked with these 2 red arrows in the same direction. And I know that line T is a transversal, and that's because it's crossing both lines S and line P. SAL. Okay, so we can, since these are parallel lines, we can use some of those theorems that we just now came up with. I know that angle 8 is 120 degrees. That's the only thing that I know right now. So what I can do is I can use all sorts of angle relationships in here to find all the missing angles. Okay, so let's start with something that we understand right off the bat. Well, I know that since angle 7 and 120 are a linear pair, I can find angle 7 by subtracting 180 and 120. So use linear pair and do 180 minus 120, which is 60 degrees. So angle 7 is going to be 60 degrees. Okay. All right, and then we're going to go on to the next angle.